Hi guys, what we're looking at today is the Baumol model, which is a cash management model. One of the two cash management models. There's the Baumol model and there's the Miller-Orr model. And the Baumol model basically shows us the target cash balance a firm should hold when, for example, there is a business sector and the business sector is marketing and it needs £1,000. What's the best way to give them that £1,000? Is it to give them it straight away? Is it to keep it in the marketable securities? Or they're the only two reasons. So let's first start off by deriving the formula for this. So there's two costs involved. There's the transaction cost, and the transaction cost consists of selling these marketable securities. So let's say you want to sell a house, there's going to be a brokerage fee. So that's an example of a transaction cost. Next, we have the opportunity cost. An opportunity cost will be the interest lost from not having that money in the marketable security. And we're assuming that there is no interest, a 0% interest rate in the current account. And the current account is where the money goes. Okay, so let's look at each of these in turn. So, transaction cost. So we're going to have a transaction cost. So by looking at this graph, as the cash balance rises, the transaction cost is going to fall, because if you're going to take out a larger sum of money at once, there's going to be a little transaction cost. For example, let's say the transaction cost of selling £1,000 worth of marketable security, let's say the marketable security is worth £1,000, and we sell it off in chunks of 10. Now, if we were to sell it off in chunks of 10, that would be 100. 100 times, let's say the transaction cost is 50, that's the brokerage fee. That's going to end up costing 5,000. Now, if we break it off into less chunks, let's say 10 times 50, it's only going to cost us 500. Therefore, the chart for this, I'll do it in a different colour, well, the line for this will all become clear as to why I'm doing this. Will look a little bit like this. I'll just call that TC, transaction cost. Okay, so I'm going to rub that bit out now. And now what we'll look at is the opportunity cost. So for this opportunity cost, let's assume that it is the money in the marketable securities make a 10% return per annum, or we can call it the APR, or even the AER. So let's say it was worth 1,000 again, times 0.1, making 100 per year. However, the more money that you take out, the less, the higher the opportunity cost. Because obviously if that money's not earning this 10% interest, it's going to be earning 0% interest. Therefore, the higher the cash balance, the more money that's taken out of the security, the less you're going to make. Therefore, it is a 45-degree line like this. Exactly like that. And we'll call that one opportunity cost. Now you can see there's a point at which the two curves intersect, and at this point, this is the optimum cash balance that should be held, the OCB. And if you were to put both these graphs together, what we would see is a curve, a little bit like this. Call this OCB. And you can see there that this is the optimum cash balance. This curve will be slightly higher because each of these incur a cost, so there'll be an opportunity cost and a transaction cost. Add these together, it'll be up here. So it's double the distance here. So essentially that's how to assemble the curve, but what's the formula? So for transaction costs, what it's going to be is it's going to be the total amount of money you want over the optimum cash balance, the cash balance you're taking out, times, let's say the transaction cost, where we were talking about that £50, is F. So that's the formula for transaction cost. Opportunity cost is a little bit more complicated. What it is it's C, the cash flow, divided by 2, times by the opportunity cost of the interest rate R. And that can be seen with a simple graph. I'll draw it here. Now this is the current account. I'll call that CA. And this is going to be time. And this is going to be the cash balance. So we'll just call this C. So obviously what's going to happen is we're going to receive the money in the current account. So it's going to go up here. And then it's going to fall as it's spent. And then it's going to need to be replenished. When it's replenished, it will go straight back up to this optimum cash balance, because this is like a ceiling for the optimum cash balance. Just do that. And once again, it will go back down in this motion. But how much of this C is actually lost in our, as what could have been in our marketable securities? So we just simply take the average. And that is C over 2. And C over 2 times our R, we end up getting our opportunity cost. Now, you're probably thinking, how on earth do we equate these two to get the formula? It's quite simple. So I'll do this in blue. So we'll put this first formula, the opportunity cost. We can simplify it to CR over 2. And we're going to be equaling them. They're essentially an identity, because you can see here it's the same cost. So we can go T F over C. And from simple GCSE maths, you can figure this out. Let's times by C. So we're going to have C squared R over 2 equals TF. Let's times by 2. C squared R equals 2TF. And now we can just do a simple rearranging. C 2TF over R. And we have that little square root up there. We can and now we can just square root. Put 2 there just to make it more clear. So this is the formula. I'll write it out a little bit more clearly. C, the optimum cash balance, equals 2 times the total amount that we need times the transaction cost over the opportunity cost square rooted. And that is our formula for the Baumol model. And from then we can calculate our optimum cash balance, OCB. And then when we've got that, we can calculate, when we've got this C value, we plug it into here, and we can get the opportunity cost and the transaction cost, which will be exactly the same. So that is essentially the Baumol model. I will be doing another video on the Miller-Orr model, so make sure you check that one out. So I hope you enjoyed this, and thanks for watching.